Hey everyone, this is Algebra 1, evaluating and solving equations, easy practice problems. First thing we're going to do is evaluate algebraic expressions. For problems 1 through 3, evaluate the algebraic expressions when m equals 3 and n equals 4. So whenever you're evaluating something, they give you the value of the variable. So we are just figuring out the value of the whole expression. So for the first one, m is equal to 3. And n is equal to 4, so it's going to be 7. For the second one, it's going to be 3 times 4 equals 12, and then 4 minus 3 is equal to 1. For problems 4 through 7, evaluate the algebraic expressions when d equals 6, e equals 2, and f equals 3. Okay, so we have 2 divided by 6. We can leave it at that, or we can reduce the fraction. It goes to 1/3. 3 minus 6 is equal to -3. 2 plus 3 is equal to 5. And then 2 times 6 times f, which is 3, is going to be 12 times 3 is equal to 36. Now, we're going to solve equations with the variable on one side. So in each case of 1, 2, and 3, x is only on this side, n is only on this side, m is only on this side. And now we are solving, which means we don't have a known value for the variable, like in these last questions. None of that is given to us, so we got to figure it out. So we'll start with number 1. First thing that we have to do is isolate the variable. X is not by itself, so it has a 17. To take care of that 17, we're going to add 17 since it's a negative. So then we're going to add 17 on this side as well. This canceled out. Subsequently, X is now isolated, and then we just do the math, and that's going to be 37. For number 2, N is on the right side, but it's not by itself, so I have to isolate it. I have a -1, so I'm going to add a 1. What I do on one side, I do on the other. That cancels. Bring it down. N is subsequently isolated, and then -8 plus 1 is going to be -7. For number 3, M is not by itself. To get rid of a positive 07, I have to subtract by an 07, 0.7. So then subtract 0.7 on this side. That's canceled out. I have an M by itself, and then we have a 0.6 once we do the math. The next thing is solving equations with variables on two sides. In order to do that, there are 3 steps. The first one is to simplify, if we can. Then we're going to isolate, and then we're going to solve. So for number 1, I have 5x on this side and 2x on this side. I need to be able to combine these, so I have to maneuver. So I'm going to subtract 2x from this side, and so I have to equally do it over here. That canceled out, and then I have 3x plus 3 is equal to 0. I have to subtract 3 here so I can get the variable isolated, more isolated. Then we have 3x, that cancels out, equals to -3. And then I have an x being multiplied by 3, so I have to divide it by 3. So then I have to divide this side by 3. And then I have x is equal to -1. For this one, I have a 4s and a 3s. I'm going to take this 3s on this side. You can do vice versa. You could do -4s. It doesn't matter, as long as you do everything evenly on each side with every step that you take. But I'm going to do 3s because it's simpler for my brain. So -3s, -3s. That cancels out. And then I get s minus 2 is equal to 4. I have a -2, so I have to put a +2 to isolate the s. Then I have s is equal to 6. For the third problem, I have a 6c and a 4c. I'm going to subtract the 4c on this side and that side to cancel that. So I have 2c minus 10 is equal to 10. I'm going to do a positive 10 to get rid of a negative 10. So I have to do the same thing over here. And I have 2c is equal to 20. Divide by 2 to isolate the multiplication by 2. And c is going to be equal to 10. So now we're going to step it up a little bit and get to intermediate practice problems. We're still doing the same thing we did last couple of pages, which is solving equations with the variable on one side, but these are a little bit more complicated, maybe because they have more terms or there are fractions involved. Fractions always make things longer in algebra. Okay, so for number one, I have x divided by 3 times 27. The variable is only on one side, but to isolate it, if I have it divided by 3, I have to multiply it by 3. So I'm going to multiply it by 3. So on this side, I multiply it by 3. That canceled out, and so you have x is equal to 81. For the second one, I have 4 times x. So I need to divide by 4. Divide by 4. That cancels, and then I have x is equal to negative 4. Number 3, I have something being multiplied by negative 3 to the variable, so I have to divide it by negative 3. Divide by negative 3. Z is equal to, when you do the math in a calculator, negative 3, because you have a positive and a negative, 0.133. For number 4, I have 2 divided by 9 times b equals 18. This is a situation where you have another fraction. You can also rewrite this because this is technically a b over 1. So if I wanted to, I could bring the b more up. Oh, dang it. Let's see. Okay. Let's do it like this. Right? And then I'm going to multiply it by the inverse of this fraction. So if I have 2 over 9, I have to multiply it by 9 over 2. So that can cancel out and that can cancel out. I'll end up with b, but whatever I do to one side, I have to do the other. So if I multiplied it by 9 over 2, I have to multiply this over 9 over 2. Then we do the math. I'm going to simplify this fraction and this whole number. These 18 and 2 have a common factor. This is really 1, and then this becomes 9. So then it's 9 times 9 is 81 over 1, which is also equal to 81. Okay, so for the fifth question, something similar. This is 4s over 3. To get rid of the 4 over s, I have to multiply it by 3 over 4, the inverse of that fraction. So this side is going to be 3 over 4 as well. That cancels, and then I have s isolated, and then I have to do the math on this side. None of these have common factors, so I just multiply across at the top, multiply across at the bottom. 3 times 5 is 15, and 4 times 2 is 8. And I'm going to leave it at that. This is called an improper fraction because it has a higher number at the top. But you could change this improper fraction to a mixed fraction, but I'm just going to leave it at that. You would be right either way. For problem number 6, something similar. So this is just so we can practice and be familiar. If you have something multiplied by 2 over 6, you can multiply by its inverse of 6 over 2. So then do it on the same side. That cancels, we have j. And then this is technically over 1. That can be broken down. This can, though. They both have a common factor of 2, so I'm going to make that 1. This is going to be 51. And then 51 times 6 is 306 divided by 1, or J is equal to 306. Solving process starts to take longer because it involves more multi-steps or fractions. So we'll do number 7. I'm going to isolate the variable. We're going to simplify as much as we can. So I have the ability to add 5.7 because it will make the variable side smaller and more simple. So it's going to be 7.2 over 1.2b. Then I'm going to divide by 1.2 to isolate b. I'm going to end up with b is equal to 6. 8 gets a little tricky. This is more fraction things. So I have 2f over 5 minus 1 over 2 equals 5. I could bring everything over, which is, I'll do that. So let's see. I can bring over the 1/2. Then I have 2f over 5 equal to 5 plus 1/2. I have fraction, fraction, whole number. I would like to make all these fractions have the same denominator for simplifying the math process. So that means we have some fraction stuff to take care of, and I'm going to put that here. So the first one is 2 over 5. For these three, what would be a common denominator that they both have? The closest one is, it's not 2, it's not 5, it's not 6, it's not 7, it's not 8, it's 10. So I'm going to make the 2 out of 5. I'm going to convert it to have a denominator of 10. In order to do that, to go from 5 to 10, you had to multiply by 2. So I'm multiplying by 2 here as well. Oh, hold on. Change different color so you can see times 2 times 2. So then that means I have a 4 over 10. That's for the first one. Now I have 5. I need to make that into a fraction with a denominator of 10. 5 by itself, the denominator is understood to be 1, but I want to get it to 10. To get the denominator from 1 to 10, I had to multiply it by 10. So I have to do the same thing to the numerator. That's going to be 50. And then for the last one, which is 1/2, to get it to 10, I had to multiply the denominator by 5. So I'm multiplying the numerator by 5. And then I got 5. So now I'm going to rewrite all these fractions that I figured out here and put it here. So 2/5 over f is now 4/10 over f is equal to now 50 over 10 plus 5 over 10. 4f over 10 is equal to 55 over 10. And now to isolate, because I can add those together, I'm going to do 10 over 4, 10 over 4. That cancels, that cancels. I have f. This cancels, this cancels. I have 55 over 4. Moving along, we have number 9. And we have the same situation. We need to change D to have a denominator of 10. So that's going to be 3 over 1 to 10. I have to multiply that by 10 on the bottom. Top is going to be 30. So then it's going to be 30. Oh, sorry. This is got to add the D. So I'm going to subtract 2 over 10. 30 D over 10 equals 4 over 10. Gonna do 10 over 30, cancel that out. 10 over 30, that can cancel, and then I have D is equal to 4 over 30. Break that down, divided by 2. They both have a common factor of 2, so that's going to be 2 over 15. Alrighty, for the next one, more simple, gonna subtract 17 on both sides, and I have 3Z is equal to negative 4, divided by 3, divided by 3, Z is equal to negative 4 over 3. For number 11, we're going to combine like terms that we can. We have a 4b and a 16b on the same side, so that's going to be negative 12b plus 6 is equal to 16. Subtract 6, my apologies. It's going to be negative 12b is equal to 10 divided by negative 12 divided by negative 12. B is going to be equal to negative 10 over 12, which is more broken down. You can leave it like that, but more broken down is negative 5 over 6. Solving equation variables on two sides. My apologies. So for number 12, we're going to simplify as much as we can. So we have two constants that we can combine. So it's really x plus 2 equal 2x plus 2. I'm going to take that out of parentheses because it's being multiplied by 1. To combine terms, I'm going to subtract x on this side so I can subtract x on that side. I'm going to have 2 is equal to x plus 2. And then negative 2 x equal to 0. 8f minus 2 equal 3f plus 12.25. We're going to combine negative 3f, 5f minus 2 is equal to 12.25. Then I'm going to add 2 on both sides. 5f is equal to 14.25 divided by 5 divided by 5. F is equal to 14.25 divided by 5. For 14, we have variables on both sides. We're going to combine them. So negative 1.8b minus 1.8b is equal to 2.8 equal 0.7b plus 2.1 minus 2.1. So I'm going to minus 2.1 is going to be 0.7 equals 0.7b. I'm going to divide by 0.7 to isolate my variable. then I'm going to get 1 is equal to b. And then for the last one, we have variables on both sides, z and z, but we need to simplify because there's some fractions involved. I mean, some parentheses involved. So I'm going to distribute here and here. 9z is what I get for the first term, and then plus 27 for the second is equal to 6z plus 21. Gonna try to combine the variables that I can. That's going to be 3z plus 27 is equal to 21. Positive 27, I'm going to do a negative 27 on both sides. 3z is equal to negative 6. Divide by 3 to isolate the variable once and for all. Then I have z is equal to negative 2. Hope this was helpful. If you have any questions and would like to set up a one-on-one session with me, email me, and I'll see y'all in the next video.